All right, we're gonna quickly show you how to sort of add components and modify your basic circuits in Simulink, particularly when you're using Simscape. So this is an example circuit, um, and I wanted to see if I could add some components to it. In particular, what I wanted to do is kind of focus on how I could add some of the elements that we make you use in 2112. So first of all, if I want to run the model and I want to see what's going on, I click the Run button, let it run, and then take a look at the oscilloscope to see the results. Okay. Now, given the way that this is set up right now, I have kind of a funny layout, and I want to change that layout. So I go to View, Layout, and I go to, this changes the number of panes that I want to see. So if I go to something like that, I'm going to get a lot of panes that are useless. I want to change to just 2 vertically stacked, since I only have 2 things to look at. And then this scale X and Y axis limits will scale the axes so I can see everything that's going on. So let's say I try to zoom in on a particular point in time, and I zoom in with that magnifying glass. So here now, if I want to zoom in on the current, if I want to get back to the original, I look at this. If I want to zoom in, I can go like this. All right. And then back to the original, I scale the X and Y axes. Now, the other thing I can do is, if I want to make some measurements, I can make use of these cursors right here. So I click on the cursors, and then I get this window over here that lets me make measurements either on the voltage or what's called PS-S2. If I look, this is the one called voltage. PS-S2 is apparently this guy right here. All right. Block parameters PS-S2. He doesn't have a name. All right. He could be given one, I guess, if we wanted to, but we don't have one for it. All right, so let's say I wanted to zoom in and I wanted to make some measurements of some values here around time t equal to 0. Right, so I zoom in around t equal to 0. Okay, and if I want to use my cursors, I'll click the cursors like that. Okay, and then I can highlight over top of the cursors. First of all, I want to make sure the magnifying glass is off. Right, so the only thing selected is the cursor. Then when I move my cursor over top and I hold down the left mouse button, I can move this guy around. So what I can see if I look right here, okay, this says that the particular value I'm looking at right there this is for cursor number 1, is at 169.695 volts, and that's happening at time 4.143 milliseconds, okay, which is roughly 1/3 of a 60 or 1/4 of a 60 hertz period. And then this is cursor number 2, right? So I see when I move cursor number 2, it moves this value here. All right. Now notice the other thing I get is the difference between the two, so the delta t and the delta y. So for instance, if I move this guy to this peak right here, I see the delta t is about 16.6 milliseconds, which is about 160 hertz period. And I see that the delta is 11.9 millivolts, or basically 0. So the delta between this point here and this point here. If I change this to the other signal, then I'm getting measurements on the current. Okay, so that cursor is kind of the easiest way to make those measurements. All right, so now let's say I wanted to modify this guy. To do that, I would go over here to the library browser, open that up. Okay, and I get access to all of the many different things that are included within Simulink. Okay, so let's say that what I want to do is I want to be able to add circuit components like this. Well, the circuit components that we use come from a library called Simscape. So I'm going to go down here to Simscape, and I'm going to click this arrow to sort of expand this guy a little bit. Okay, and I can jump around different places to sort of see some of the important things that I need. In fact, I already see some of the important things. So let's go to the Foundation Library. So in the foundation library here, I can see there's electrical stuff, gas stuff, hydraulic, magnetic, all these things that might be useful. So here, I'm going to go to the electrical. That's obviously what we want. So I've got electrical elements, electrical sensors, and electrical sources. So I go to electrical elements, right? I find all of our sort of basic elements that we might think of. So capacitors, transformers, inductors, all these sorts of things. In this case, I want to get a switch. So I'm going to get a switch. And notice what I did was I basically left-clicked on it and dragged it over onto this guy. All right. Now, I want to modify this circuit that I currently have to throw this guy in there. So I'm going to move the switch out of the way. Okay. Simulink tries to draw circuits oftentimes in really funny ways. All right, move this out of the way. Okay. Now, what I want to do is I want to move that switch over there. So if I want to rotate that guy, I right-click on it, and I go to rotate clockwise. All right, and I want to put the switch in line. Okay, so I put the switch in line. Basically, if I look at the circuit I've got, right, so I've got some sensors and stuff, but basically I've got a voltage source which can flow current through a current sensor, through the switch, through the RL, and then back. Okay, and then I've basically said I want this point down here to be 0 volts. I always have to tell this thing where I want 0 volts to be. If I want to zoom out, what I can do is I can take the wheel on my mouse and go in and out with the wheel on my mouse. All right, I can also, all right, I'm going to try to go out a little bit. All right, now what I want to do is I want to put a control in for this thing. Now, so what I showed in class the other day is I want to have a step function. All right, so I want a step function. So there's places to find that. One thing I can do is just search here and say step. All right, hit enter. Okay, and I come up with a whole bunch of different things, including in the basic Simulink library, a step function. Okay, and I double click on them, and I want the step time to be 9 seconds. I want the initial value to be 1, and the final value to be 0, right? In other words, I'm saying that at time 9 seconds, I want this function to go from 1 to 0. Okay, just like what we talked about in class, we talked about MOSFETs as switches. Right? I want to move this thing up a little bit. We talked about MOSFETs as switches. We basically said for a switch, there's 3 terminals. In this case, there's the terminals that current can flow through. So from here straight through to this side, and then there's a control terminal. The control terminal always has to have a threshold. In other words, whenever the voltage at that point goes above a certain value, this guy turns on. Whenever it goes below a certain value, it turns off. And I can find out what that is if I click on this guy. So his threshold is 0, I see, right? So in other words, if I have 0 going into this thing, this guy is going to turn off, okay? So initially, if this is 1, and this is the control signal we're going to use, the switch will be on, and then at 9 seconds, when this goes to 0, the switch will turn off. Now, in order to use this, this guy is a native Simulink function. This guy is a Simscape function. So an important thing to kind of note about this is a lot of what we have here, all of the circuit components, including these sensors and everything, are Simscape functions. Whereas the step function, the scope, those things are Simulink functions, native Simulink. So I have to convert from native Simulink into this Simscape stuff. To do that, I need these PS and S blocks. Okay, so to find those, okay, I can simply go back to my library browser. So I click my library browser. I go back to my Simscape stuff. I go to my, in this case, my utilities, and here I see this Simulink to PS converter. Right, so I drag him over. So notice these guys are PS to S. In this case, it's going from what's called a physical signal in this Simscape environment to a Simulink signal. In this case, I'm going to go the other direction. I'm going to go from Simulink to physical. So here, I just click on that and drag this over, and now those are connected. Now I drag this over, and they're connected. All right, so we're good to go with that. Now, what I want to do is move these over a little bit closer. And I want to put a voltage sensor in parallel with this guy. So to do that, I go over to Foundation Library, Electrical Elements. Oh, wrong thing, right? Go back to Electrical. I want Electrical Sensors. So in here I see a voltage sensor. So I drag that over. Okay. Put that voltage sensor in parallel, like any voltage sensor should be. Okay. Now I'm measuring the voltage across that RL. Now what I want to do is I want to feed that output signal, which is a physical signal from Simscape. I want to feed it into my oscilloscope. So I go to my oscilloscope, click on it, then right click, and I see down here signals and ports, number of input ports. I want to change it to 3. Now I've got a third input. Okay. Now I have to take this physical signal and bring it into Simulink. So I go back to my library browser. Okay. Go to my library browser and I go back to here. So under Simscape I've got utilities. And I see that I need to go from a physical signal to Simulink. So drag this guy over and connect those. Connect those. Alright, and I'm ready to go. At this point, if I click run, it says compiling, initializing, running. So down here I see that it's running. Okay. And I can go in and I can look at my outputs. Okay. So I see that I have 12 warnings. Again, I mentioned this in an announcement. That warning's okay, right? It's talking about step sizes here. I just closed that diagnostic viewer. Anytime you're running simulations like this, you have to have some intuition about what to expect. In this particular case, I think that there's problems coming in because my RL time constant is very, very big. And it's very, very big because this R I've got in here is really, really tiny. In other words, this circuit looks pretty much just like a pure inductance, which physically is a very, very hard thing to have in the real world. And so I expect there to be some warnings from some numerical sorts of issues. I also expect that there's some numerical issues that may be coming in as a result of me opening this switch. That said, I've already looked at the output of this thing and I know that the results make sense physically, so I'm not too particularly worried about those issues. All right, that kind of intuition you develop over time, but that's one of the critical skills that you need to sort of develop. All right, so this is how you do this. We're going to continue to do this in the project. All right, so you guys will have to get a little bit familiar with this. For the most part, what we just did in this video is really enough for you to be able to understand and figure out what's going on.